All right, we are moving on to section 4.12. The start thinking part says a self-serve frozen yogurt store sells servings up to 12 ounces. It charges 50 cents per ounce for a serving between 0 and 8 ounces and $4 for any serving greater than 8 ounces up to 12 ounces. And the students are supposed to look at these different graphs and figure out which one of the graphs is going to model that situation. And then after they figure that out, they're supposed to figure out what the other graphs are actually saying. So when we look at this, the students were able to see that B was the best one. Even if they didn't look at the rate of change or anything like that, we have already looked at general shapes of graphs, and this one seems different than the other ones. This one is going up and then stays flat, and that seems like it makes the most sense of the fact that the cost would be increasing up to 8 ounces, and then after 8 ounces, it stays at $4. So even if students didn't look at rates of change or did not understand the graph completely, they would be able to figure out that B was the correct one. Now let's go through the different ones. For A, if we're asking what is actually happening here, you can see that the cost is increasing pretty consistently. And not only that, but we could look at the rate of change. That is up by $1 for 2 ounces, which is the same thing as 50 cents per ounce. So it just says just costs per ounce, and it's 50 cents per ounce. When we look at C, that is, it's hard to see on this one, but you can see it on your version. There's a flat line at 4. So that is saying for 1 ounce, 2 ounces, 3 ounces, 4.7 ounces, any of those, it's always going to be an output price of 4. So that is just a constant price of 4 no matter how many ounces between 0 and 12 ounces. And the last one is also a constant rate of change. The only difference is it seems like it goes up by $1 for 3 ounces. So that tells you it is going to be 33.3 cents per ounce. And there is no point where it is just going to even out and the cost just stays the same. So that is what all of these graphs mean. We then took a look and tried to figure out what would be the best. If you could pick from any one of these, which one would be the best? And if you graph all of these on the same exact graph, you find out there is no time that any of these are going to have a lower output than D. Going over and saying 33.3 cents per ounce will always be the cheapest option if these were your 4 options. So that was that. The next thing we looked at was the domain and range of our original one, B. Now you can see the domain is going from 0 to 12. I said including 0, but you could have not including, because you could say, hey, if they have 0 ounces, then they didn't buy it, and this isn't even part of the situation. So we talked about whether 0 should be in there or not, and it kind of came up to the interpretation. But the domain is going from 0 to 12. The range is going to be going from 0 to 4 for the situation on B. So this kind of wraps up a lot of the stuff we've talked about. Rates of change, general shapes of graphs, domain and range, all of that is embedded in here. After that, we talked about the equations of the lines. So A would have an equation of y equals 1/2 x plus 0, because it has a slope or a rate of change of 1/2 and a y-intercept of 0. C would have an equation of just y equals 4. And D would have an equation of y equals 1/3 x plus 0. Then I said, what would be the equation for B? And the problem here is that there's different aspects of the graph. There would be one equation from 0 to 8, and there would be another equation from 8 to 12, because there is one that is kind of a diagonal line, and there's one that is going to be a flat line. This brought us to the concept of something called a piecewise function. And what that basically is it's going to tell you what the equation of the line is going to be between certain intervals. So in this case, between the interval of 0 to 8, the equation would be y equals 1/2 x plus 0. Then between 8 and 12, the equation would be y equals 4. So there's different equations for different parts of the graph, for different intervals. Now, when we look at this one right here we have an application. The application is talking about what a piecewise function is. A piecewise function is a relationship between postage rate and the weight of a letter. It's a piecewise function because you have different aspects of the domain, different intervals where the output is going to be different. So in this case, we also call this a stepwise function because it looks like a little step. So on here, you can see between 0 and 1 ounce, it is going to be a single cost. Between 1 and 2, it's going to be a single cost. Between 2 and 3, it's going to be a single cost. And we don't hit all of the values in between that. We are only staying at that value for a while. This makes sense. Let's say you went to downtown. You're going to pay $1 if you stay for 0 to 1 hour parking in downtown. Then from 1 hour to 2 hours, you pay $2. Then from 2 to 3, you're never going to pay $1.50. It's like blocks of costs. So on here, we had to figure out what the price was going to be for 1 ounce, 1.1 ounce, and 0.9 ounces. So if you look at this for an input of 1 ounce, you can go up, and it seems like it could be on 2 different steps, either the 50-cent step or what I called 75. It's probably closer to like 74, it looks like. I didn't realize that was off the line a little bit, but about 74. And since at 1, the dot is closed at the 50 cent, then that means that it is going to be 50 cents. 1.1 is going to come from the next step, which is, I'm calling it 75 cents, but it looks like it's down from that, about 74 cents. And then 0.9, if you do an input of 0.9 and you go up, you are going to see that it hits the step that is 50 cents. It says the letter cost 92 cents to mail. How much did it weigh? Well, you can see the output of 92 cents. There is a spectrum, or like an interval, from 3 to 3.5. Actually, no, that would be the other one. So for 92 cents, that's actually going from 2 to 3. So I wrote down the interval. The weight in ounces has to be somewhere in between 2 and 3. Now this next one is saying, try to figure out what the error is. Someone went over and tried to write the rules for the postage, but something went wrong. And what went wrong? So on this first one, the issue is if you look at the one above, there is never going to be a closed dot over a closed dot, because then it's no longer even a function. And it's going to be saying that, like, let's say that at 1, it was a closed dot for the 50 cent and it was a closed dot at the 75 or 74, whatever that is. That would be saying that 1 ounce could have 2 possible costs, and that wouldn't make any sense. So when you're looking at this problem right here, they're all going to be closed dots. All of those intervals are going to be capped off with closed dots. That's a problem, because that would mean 1. Where does 1 show up? Well, 1 is in 50 cents and 71 cents. 2 is in 71 cents and 92 cents. That's a problem. Now, we have kind of the exact opposite issue for the next one. 1 is not under 50 cents and 1 is not under 71 cents because they both are using open dots. If they're both open dots, then in this case, it's saying that 1 is not for 50 cents or 71, 2 is not for 71 nor 92 cents. And you have this issue because it is not one of them closed and it's owning that part of the domain. It's both of them are open, and it says for that part of the domain, for 1, there is no output, and that would be a problem. Now, the next one here, we have a situation. You are renting a bicycle. When you're renting this bicycle, there's going to be different prices based on how long you're going to rent it. Now, it is going to be $2.50 for the first 30 minutes, as you can see there, then $5 for the next 30 minutes, then $7.50 for the next 30 minutes, and so on. So this is a piecewise and step-wise function, as you can see here, because you are never going to hit $3 that you have to pay. It's either going to be $2.50 or jump straight to 5 or straight to 7.5. It is a piecewise function. And we went over and graphed this. So you can see the graph that we had. I always put it in open dot when they just had the less than or the greater than and not the or equals to. And I put a closed dot when they were saying that you had less than or equal to or greater than or equal to. And you can see the graph that I have on here matches up with the piecewise function. We also went over and filled out a table here. Now, the only funky one is 0. When they say 0 minutes, 0 is not in any of those, because it says, you can see that on that first one, it's $2.50 if it is greater than 0, but we have no idea what it is at 0. We would assume you pay $0, but we're not quite sure. The next one says, describe in words the pricing rules. So the cost up to 5 hours is going to be $2.50 per 30-minute block. Then $15 for 5 hours to 12 hours is basically the concept here. Now the domain is going to be from 0 to 720 minutes, not including 0, but including 720. How did I get that? Well, I looked at the notation on the piecewise function, the function notation, and you could see the bottom one says going from 150 to 720. And then the range. Now you cannot say the range is going from $2.50 to $15 using interval notation, because that's saying you can have a output anywhere between those. Instead, I just wrote out the numbers that were inside of my range. It's either $2.50, $5, $7.50, $10, $12.50, or $15. Now on this next one here, this one is a real piecewise function. This is not just a bunch of horizontal lines. So what this is telling you is that you want to have the graph of 1/2 x plus 1 for any values of x between 0 and 3. You want to have a horizontal line y equals 3 between 3 and 5, and you want to have the other equation -1/3 x plus 6 between 5 and 10. So what I did was I graphed all these. I kept all of the parts of the graph, and then I erased the parts that I didn't need. So originally that bottom line that has a y-intercept of 1 just kept going. And then I knew that it only went from 0 to 3. So I decided to cap off at 0 with a closed dot and cap off at an x value of 3 with an open dot. And then the other one, the horizontal one, I had a closed dot at 3 and an open dot at 5. And then the other one I had completely graphed. You can't see it here, but I went over and erased the part that didn't actually exist, and I capped it off with a closed and an open dot. So this would be a piecewise function, different lines, based on different intervals in the domain. Now let's take a look at the homework here. On this one right here, you are supposed to be finding out with this piecewise function what are going to be the values for 3, 7, and 10 as your inputs. So you could either look at the function notation or you could look at the graph. 3 is going to be, when you actually look at an x value of 3, it's going to spit out a 1 that is between 2 and 5. 7 is going to be an output of 0. The reason why is if you go to do an x value of 7 and go up and find out where the closed dot is, because it's at the border, it is on the one where you have a horizontal line with an y value of 0. What about 10? Well, 10 doesn't exist. If you look at your graph and you look at an x value of 10 and try to go down, there is no piecewise aspect there. And then lastly, it says g of x is going to equal 2. When does it equal 2? It's going to equal 2 from -1 to 2. I did it in interval notation. Number 2 is saying, is this graph here going to be a function? Explain your reasoning. I said no. It could have been if they were more careful with the open versus closed dot, but in this case, since you have those 2 closed dots, you do have a value of input of 2 that has 2 outputs, as an output of 7 and an output of 1, and it does not pass the vertical line test. So that would be that. Next one is a little bit of a review. It says Tirza is paid $100 for the day and then $20 commission for each warranty plan that she sells. The function modeled is E of W equals 100 plus 20W, where E is the earnings, W is the number of warranties sold. Name one value that would not be part of the domain and one value that would not be part of the range and explain why. So the issues I saw for domain is you can't have any negatives because you can't sell negative warranties. The decimals don't make sense because you're not going to sell part of a warranty. And for the outputs, no negatives make sense because she's not going to make $0. You could also say no numbers under 100 because she makes that flat $100. And no non-multiples of 20 because she is going to be making money $20 at a time because it's $20 per warranty. So you guys could have picked any one of those. On this one right here, a parking garage is going to charge $5 from 0 to 1 hour, $10 over 1 hour to 2 hours, and then $12 for 2 hours and for the rest of the day. You were supposed to graph this. So on here, it says that you do pay $5 if you are going 0, including 0, all the way to 1. That's why I had those capped off with closed dots. Then it is going to be $10 for over 1 hour, so I had to use my open dot, and then go to 2 hours where it was a closed dot. And then $12 was from 2 hours onwards. That's why I had the open dot, because it says it has to be over 2 hours. I filled out my table over there. It says think about how many, it says is G a function of T? And it says think about how many costs there are for a single number of hours. Well, for one number of hours, there is only one cost. So one input has one output. So yes, and it's going to be passing the vertical line test. Then they ask you to flip it. Is t a function of g? It's basically saying, think about how many possible hours there are for a single cost, because we're flipping the whole thing. And when you do that, is there only one possible number of hours for a cost? No, there's multiple. So that would not be a function. T is not a function of g. And then our last one here was just a little review, making sure that you guys knew how to graph the linear inequality. We would graph the line with a y-intercept of 7, and you would go down 2 over 3. It would have to be dotted, not solid, because it is less than and not less than or equal to. And when you test the point 0, 0, you end up getting 0 is less than 7, which is true. So you're going to want to shade in the direction of 0, 0. It then asks, is this going to be a function? So for an input of 5, is there only one output? If you're only looking at the border, it seems like there is, but every point that is shaded is one of the solutions. So you have 5, 1, 5, 2, 5, 3, 5, negative 1, 5, negative 2.75. So for 5, there's many different outputs. So the answer is no, does not pass the vertical line test, or there is going to be an input that has more than one output. All right, hopefully piecewise functions made sense. As I said, the main concept here is that you are going to have different values or different equations. For example, in here, 1/2 x plus 1 versus 3 versus negative 1/3 x plus 6 for different intervals. Thanks for watching.